We introduced quantifiers right now. Now we can nest these quantifiers, especially when we have more than one variable. In order to make a proposition function into a proposition, we will need to use nested quantifiers. When we use nested quantifiers, one of the key things is we have to pay attention to the order in which they are used. It matters the order in which they are used. You cannot just switch the order unless the quantifier happen to be of the same type. But otherwise, changing the order of quantifiers will give you a different formula than the one you started with. Let's look at quantification over two variables. So in that case, we have two quantifiers, one for x, one for y, and each quantifier could be either a universal for all quantifier or an existential quantifier. And so we have a total of 4 possible combinations to worry about. The first row and the last row, the order of the quantifier doesn't matter, because in the first row all quantifiers are universal, in the last row all quantifiers are existential. So that's why we have put both of these in the same cell, because these two formulas are the same. These two formulas are the same. So let's see, when is this formula true? When is this formula true? In order for all x, for all y, p of xy to be true, essentially that means no matter which x and y you choose from the appropriate universe of discourse, the formula must evaluate to true. It is false if there is at least one pair where the formula evaluates to false. The formula that exists x, there exists y, p of xy is true if you can find one pair where the formula is true, and if you could find one pair where the formula is false, if you could show that p of xy is false for every pair x and y, then that means the formula that exists x, that exists y, p of xy is going to be false. Think about this. If there are questions about this, this is something we should discuss in class. This quantifier in some sense is easy because we have the same quantifier used for x and y. The next is a more complicated scenario where the quantifier for x is different from the quantifier for y. Okay, so let's look at this particular formula. For all x, there exists y, p of xy. So that means no matter how I choose x, I should be able to find a y such that p of xy is true. For every x, there is a y such that p of xy is true. In this case, y may depend on x. That means once x is chosen, then you can choose y. It is false if you can find one x for which no matter what y is, p of xy is going to be false. So in this formula, you can think of it as a game. The first person chooses x, the second person chooses y, and the goal is to evaluate the formula to be true. The other formula, you have there exists x for all y. So that means you have to find x first, and once you find that x, no matter what y is, p of xy should evaluate to true. So there is a fixed x such that for every y, p of xy should be true. In other words, once x is decided, we can't change what x is while choosing y. Once again, Uh, this thing is something that is potentially complicated. So if you have questions on this, I want to make sure uh, you put those on Piazza as well as discuss it in your group. Some of these things will become clear once we look at some of the examples. But this things is somewhat complicated. Is sort of the most complex things that we have done so far in this class. So if this sounds a little confusing, it's fine. But at the end of this module or after the class, it should be something that there is no confusion about it. So let's look at an example. Let's say p of xy is the predicate x plus y is equal to 5. Let's say the universe of discourse for both x and y is 1 through 4. We want to find what is the truth value of for all x for all y p of xy. You can see the second one is there exists x, there exists y, there exists x p of xy. Let's look at an example. Here p of xy denotes x plus y is equal to 5. Let's say the universe of discourse is 1 through 4 for both x and y. The question is, what is the truth value of for all x there exists y p of xy? And what is the truth value of there exists x for all y p of xy? At this point, I would ask you to pause the presentation so that you can work on it yourself. When you are ready, you can go to the next slide. Next slide, I have the solution on the slide. But I would highly encourage you to find the answer yourself before you go check it on the next slide. So this is the solution. The formula for all x there exists y p of xy is true because no matter what x is chosen, I can find a y such that p of xy is true. So our universe of discourse is finite, so we can look at all possible values of x. X could be either 1, 2, 3 or 4, and then we can choose y to be 5 minus x, and it is still in the universe of discourse of y. Now let's look at the other formula. This formula is false because once I choose x, choosing x is the first thing I have to do. Then for that fixed x, we cannot guarantee that x plus y will be 5 no matter what the value of y is. So I want to use this example as a way to also illustrate that changing the order of the quantifiers, in fact, if you look at the two formulas that we have, all that we have done is we have changed the order of the quantifiers. That is something that is not allowed. Once again, we have reached the check before you proceed slide. What I want you to observe from this module is the order of quantifier matters. We looked through examples where changing the order of quantifiers changed the meaning, and therefore it changed whether the formula evaluates it true or not. I want you to understand how does the changing of quantifier change the interpretation of the formula. In other words, if I have a universal quantifier followed by existential quantifier versus if I have an existential quantifier followed by universal quantifier, how does it change the meaning of the formula? We have reached the end of the module, so please do the review quiz for this module.